Right, so the chapter 10 on installation, I don't really have much to say on that one because we are going to look more at the Årsdal field in the next appendix. So that we will get to look a bit more at the installation part there. I will also have a couple of clips to show at the end of this presentation. So we're just going to move past one on installation. We do have this one though, which is let's see. This one shows a tie-in operation. So it's in the middle of the Baltic Sea between Sweden, Finland, and the eastern European countries. And they're going to connect two pipelines. Just right in the middle there. So they started off in two ends, put down the pipelines, and then they met at the middle, and now they're going to connect them. These yellow tips here, they are more for when they were lowering them down with wires. So it was sort of to get a grip on the pipelines. So first they lowered down this cutting tool. So they cut off these lifting tips. And then they do another cut there, so they cut off a smaller segment of the pipeline. They do the same on the other pipeline. Then they move these tips away just so that they're not in the way while they're working down there. They don't need to retrieve them to the surface yet, so they can just move them a bit away so that they're not right where they're supposed to be working. And they do the same for the other pipeline. Then they strap on these balloons, which they're going to use to lift the, or basically make the pipelines more buoyant, so that they don't weigh that much. And they come down with these huge contraptions that are going to lift the pipelines. They can also move sideways once they've lifted the pipelines. So now they've lifted the first one. They're coming down with a plug tool, basically. So they lower the pipeline down onto here. And now they can place the plug into the pipeline. So all of the yellow stuff here is just a frame, basically, in order to guide this plug into the pipeline. Then they come down with a cutting tool so that they can bevel the edges. So they're making a chamfered edge on the outside so that they can do welding afterwards. So they do this on both pipelines. Then they move them as close to each other as they can have them with these huge contraptions that have lifted them up. That's to see where they're going to cut, so that they cut them at equal length. And then they start aligning them to make sure that they get them completely in line when they're going to weld them. Now they're pulling one of the pipes a bit back just to make several marks to see where the movement of the pipe is going. Yeah, now they're plugging the other pipeline. I thought they did both of the plugs first. So what they're not showing here is that there will be loads of ROVs around here, just doing all of the work. Now they start beveling the edges of this pipeline also. And now they need to prepare it for the habitat, because they're going to weld this, and if you weld in water, you're going to get very poor welds. So what they do is they lower down this really huge mechanism on top of the pipes. It has these grabbers on each side, which will grab each of the pipelines so that they can position them perfectly inside the habitat. And you see these others are lifting them just to get everything into line. And then inside this habitat they remove all of the water, so they pump in oxygen, pump in an atmosphere. Not quite sure if they're using regular atmosphere, or if they're using a special gas composition in this case, but at least make it into an atmosphere so that there's no water in there. And then they put on these robotic welding machines, which weld all the way around. When they're done welding, they can start recovering much of the equipment. So they lower down the entire pipeline to the correct position, remove all of the balloons, and then they can remove these huge ones. These huge lifters, they are hydraulically operated, but they need such a high amount of fluid running through them that they won't run them on oil, so they're running them on seawater. So they're just pumping in seawater and pumping it out. So they have to really service them between each usage. So every operation they use them on, when they get them back on land, they basically have to take it all apart, clean it thoroughly, make sure that there's no more salt water that can corrode inside the system, and then they have to put it back together again to keep it ready. They actually have there are several of these systems, and they have a similar system here in Haugesund, actually, on Chilling, where they have a pipeline repair system base, which is sort of an emergency unit for if there is a break in a pipeline somewhere in the North Sea. They are supposed to be ready to just throw all of their equipment onto a vessel, get it out there, and start working on repairs, just to avoid as much pollution as possible to the environment. So the next chapter is operation. I don't really have anything for the presentation on this one either. It's not, as you can see, it's not a big chapter. It's less than half a page. Mainly, we've covered most of it as we have gone along talking about it, so it might be nice to just read quickly through it if you've got time for it. So talks a bit about problems during operation that can occur, the control systems, and a little bit like that. We'll go on to the maintenance parts. So for maintenance of seabed equipment, we often have a guideline running to retrievals that can be done, and we can do diver retrievals and ROV retrievals. So these are three different ways of retrieving equipment from the seabed. So either you can use these sort of running tools, which you lower down on guidelines. You connect them to the module that you're going to lift up, and then you lift it along the guidelines. Or if it's fairly small equipment that's going to be retrieved, it could be done directly by a diver, and he just moves it over to a basket, which is then lifted. Or an ROV, which also does the same, just places the equipment into a basket. The baskets are basically large steel baskets. They're nothing more than that. It's also why they're called baskets. So they're heavily used offshore to transport equipment. It looks sort of like a container, only with no roof on it. So it's easy to lift things in and out of them. We're also going to see a clip here, but this one isn't on YouTube, so I have it here. We can get it full screen. So this one is without any sound. So starting. there it is. It takes a while to start. It's fairly dark in the start here. So this is in the Kristin field outside of Norway. And they're going to replace a choke module inside here. So this is the choke valve on the Christmas tree. So it's been separated from the Christmas tree so that they can actually exchange it itself. And here on the top, you can see the hole there is where they're going to connect the running tool that's going to lift it afterwards. So it's placed all the way behind the Christmas tree there. So now they lower down the running tool. So you still have an ROV or a diver doing the work down here, but the equipment is too heavy for the ROV or diver to move, so they need to use this running tool in order to be able to lift it. So in this case, it's an ROV that's doing the work, which is usually the case outside of Norway. And here we see this is a hydraulic stab, so it's a quick connection that can be used subsea. And now he's going to isolate the latch operation. This valve operates the latch itself, and this valve operates the elevator, which will lift the choke module into the running tool. So we have pressure and return gauges. And we have pressure gauges for the latch being locked or unlocked, just showing what's happening in it. And the same with the elevator. If it's going up or down, it's going to show how much pressure it's working with. Yeah, and I mentioned that was the ROV hot stab receptacle. And this is just a parking spot to put this dummy receptacle is usually placed inside the hot stab before the ROV reaches it. So it just exchanges it with its own. So these hoses are going to the hydraulic power supply inside the ROV. So it's actually the ROV that is doing all of this, or powering it. So now he's putting on the pressure on the elevator. So first he's lifting the elevator. So he's lifting it a bit up, and now he is doing a manual release. This is a safety lock feature, which was in place while it was running down to avoid the elevator suddenly breaking free and running all the way down. That would have been a problem. So that's why he lifted it up first to put the weight off of the safety lock, and then he opened the safety lock, and now he can put it back to regular pressure on the elevator. And now he's lowering the elevator, so you can see it in the background here, it's going down. And this is inside the running tool, and now you see the tip here, which goes into the hole on top of the choke module. And now he's operating the locking dogs beneath there. So this is inside the hole, and these are being deployed now, so that they are locked into place, so it can't be pulled up without pulling the choke module with it. Now he's isolating the hydraulic pressure again, so that he can retrieve the hot stab. Now he needs to go and get a torque tool in order to continue the operation. And this is one kind of basket, which is often a tool basket for ROVs, where they are fairly open, but you have tooling for the ROV which is locked into place inside the basket. So there's another dummy receptacle for the hot stab, or a dummy hot stab, and there's the receptacle for the ROV hot stab. And there's the locking mechanism that keeps the tool in place inside the basket while it's being lowered down. So now he's released the tool. There's the hot stab from the ROV, which he puts into the hydraulic connection. And now the ROV can lift the torque tool. And this is actually one thing to consider here. This is sort of a silly design that they've done here, because the ROV now has to lift the torque tool straight up, and now it has to pass it from one manipulator to the other in order to get the correct grip. So instead of having it vertical in there, if they had locked it in place horizontally inside the basket down there, he could have grabbed it in the correct location straight off and not having to, because this is a situation where it could be that the ROV pilot loses the grip on the torque tool and it falls down, so then he has to go back down and get it, and you can lose quite a lot of time just fooling around like that, doing small mistakes. But that is often a case of an engineer designing equipment and he doesn't really know how it's going to be used. So he does his best, but if an ROV pilot had been there, he would have probably told him to do it another way. So now we connected the torque tool into the receptacle where it's supposed to be. Now it starts turning around, and you can see the huge threaded bolts here that are opening everything as they are turning. So they open the clamp of the choke module itself. So now it's back to the control panel. It stabbed the hot stab into the receptacle. And now it can start to lift the entire choke module off. So now it's running the elevator all the way up. And now the choke module is inside the running tool. Now it connects the safety lock again, because they don't want the elevator being loosening and falling down as they are lifting everything. So now it's mechanically locked, so the elevator can't move anywhere. And then he releases the pressure on the elevator. And then he actually bleeds off the pressure, so that the elevator will drop down very slightly until it's resting on top of this safety lock, so that it's completely locked in place. And it retrieves the hot stab. And the running tool can be lifted up to the vessel. And if you remember some of the clips that we've seen with ROVs, it's not as easy as this. So the ROV can't just put something in, because the ROV is going like this all the time. So it takes a lot more time than it looks like in an animation. It's a lot more difficult in real life than what it appears to be. This is one of the last figures in the appendix, and it's sort of showing the necessary sequence of doing a retrieval like this. In this case, they're going to go in with wireline equipment, and they're going to exchange the surface-controlled subsurface safety valve. So the first thing they do is that they remove the protection roof of the protective structure. So whether it's a hatch that they are opening, or if they're actually lifting the roof off and placing it down by the side. Then they come down with guide wires. That's the second thing they do. So off with the roof, down with the guide wires. Then they are removing the Christmas tree cap. So they remove the Christmas tree cap. Then they come down with the riser, I think it is. an 11-inch riser for circulation. So they place this down on top of the Christmas tree. And then they go into the Christmas tree with their wire line. So they go deep into the Christmas tree, down into the well where the surface-controlled subsurface safety valve is. And then they retrieve that one, pull it up. And they bring a new one all the way down again into the Christmas tree, put it into the correct place. Then they retrieve this riser package, and they lower the Christmas tree cap into place again. And they retrieve the guide wires, and then they put the protection roof back into place. So sitting in a meeting room planning this, it looks really simple. but I can promise you this is going to take at least a day when they're doing all of the work out there, because there's a lot to do here and a lot of operations for the ROV to handle before you enter with a wireline system, and the wireline system takes some time to do its work, and you're going to lift stuff up and down. So depending on how deep this is, if this is a really deep field, maybe a kilometer or maybe 2 kilometers deep under the surface of the ocean, then it's going to, just lowering down equipment will take half an hour to an hour, just lowering it all the way down to get there. So you're basically going to use more or less a full day just lifting and lowering equipment. And then you also have to have time to do stuff down there. So usually on offshore vessels, most offshore vessels operate with 12-hour shifts. So they have at least 2 crews. So one crew working a 12-hour shift, and then they exchange so that the next crew can come on, and then the first crew will go and sleep and eat and do everything that they need to do in their off time, while the other crew is working their 12 hours, and they switch around again. So it's often a very hectic life when they are out there working. And they will quickly be, in an operation like this, they will quickly have to switch crews and then continue the operation into the night. So it's, it doesn't really matter if it's really deep, and you'll have to have lighting anyway, because there won't be any light down there by itself. So if it's dark up on the surface, it doesn't really matter down there. Yeah, we'll look at chapter 13 a bit with the workover considerations. So we have several kinds of risers, which are the pipes going from this seabed up to the rig for a floating vessel. So we have fully integrated completion style risers. We basically have everything you need for the riser. Then you have the scaled down marine drilling riser, which is mostly just used for drilling. So for when they are actually drilling the wells, they use a sort of scaled down version of the regular risers. Then you can have one or more tubing strings fitted with a common connector, so that you are connecting them as you go along. And then you also have the ones that we've been looking at for flow lines, where they are flexible. And most of them use some sort of flexible riser nowadays. It's just at least the impression that I've gotten from the people I talk to in the industry is that mostly, at least newer developments, are using flexible risers. Basically just because they afford you a better weather window, so you can afford having worse weather while you are still operating, because they can handle more stress and strain. So now we have one last illustration from the appendix. I think there is supposed to be one more. There's supposed to be a figure 13.2, but for some reason we don't have it in our appendix. It's not in the Norwegian version either. So probably slipped through when it was created in the first place. Here we see a more complex situation. So here they are going to do a lot more while they are working. So you can see in the previous one we had 5 things that were going to be lifted off and 5 things that were going to be lowered down. So 10 steps in all. Here we have 7 things being lifted off and 9 things being lowered down. We have 16 steps in all, so it's going to be a very large operation. operation. And we'll start off more or less the same. We're going to lift off the protection roof of the structure, lower down the guide wires, connect them into place. Then they are going to lift the Christmas tree cap off of the Christmas tree, coming down with the 11-inch riser. And this one is for, yes, the same kind of riser which was on the last one for circulation. And then they are going to do wireline service. That's when it's these dotted lines, they're doing wireline service. So they're going to set plugs in the tubing hanger with the wireline. Then they are going to lift off the entire Christmas tree with the 11-inch riser. Then they're coming down with a blow-up preventer, putting that one in place, exchanging it for the Christmas tree basically. And now they're pulling the tubing hanger with the 11-inch riser that they used to pull off the Christmas tree also. And then they're coming down with a new tubing hanger. So that was the point of this operation, was to be able to exchange the tubing hanger inside the well. So this is quite an extensive work to be done. And then they come down again with wireline equipment, and now they are putting plugs into the new tubing hanger inside the well. They're plugging it up because as soon as they have the plugs there, they can remove the blow-up preventer. Now they are removing the blow-up preventer and they are putting the Christmas tree down into place. And when they've gotten the Christmas tree into place, they can pull the plugs with the wireline equipment. So they can remove the plugs from the tubing hanger. They put the Christmas tree cap back onto the Christmas tree. They remove the guide wires and put the protection roof back into place. So now they more or less dismantled all of the seabed equipment, and they've been inside the well, and they've exchanged some of the equipment inside the well also. And because they were exchanging more stuff than just exchanging the safety valve down there, since they were actually pulling the tubing hangers out of the well, they had to have a blow-up preventer in place just to be on the safe side. Yeah. So I've mentioned several times that this is an old appendix, so it's not quite up to date. So for the future of the oil and gas industry, at least out to sea, it is that more and more stuff is being placed on the sea floor. So we are going to see more and more stuff being placed on the sea floor, so long as it's not very shallow waters. So if you're just at 100 meters of depth, you can just as well put a regular rig on top of it, because they cost more or less the same, so it's not really a problem. But when you're getting into deep waters, the subsea wells suddenly become more profitable than using a very expensive rig, because the rigs become so expensive when they are very deep. Especially if you can do the system where you are doing most of your stuff down on the seabed, and then you can just load it up onto a tanker which is storing it until a larger tanker comes to bring it off to wherever it's going to be sold. So you will have a lot of equipment running very reliably down by the seabed, and you won't have to have a lot of crews working around the clock on top of the rig in order to keep everything running. You basically just have regular 8-hour shifts on a control in a control room, which actually can be situated on land. So you can have the control base for the entire subsea field placed on land, where they can sit and they can work regular 8-hour shifts, so 3 shifts each day, so that they can do regular days, which is much more economic than sending people off to boats, having them work 12 hours a day for 14 days, and then sending them back home and having to let them rest for several weeks before you can send them out again. So it's a lot cheaper to have them working onshore instead. So this is some of the equipment that's in well, I'm not sure if everything has been developed yet, but they want to develop separators to separate the fluids in the well flow. We have both gas and oil coming in, and you can start separating them and sending them into one gas pipeline and into one oil pipeline. Other separation systems, cyclonic, gravity separator, modularized seabed processing system, it says here on this one, which means basically just putting all of these different modules into one template, so everything interacts, so that you get everything working just as if it was placed in a processing plant on shore, so you have everything gathered in one place, instead of creating these structures for every single one of the different equipment. You have booster pumps, seabed compressor, and multi-phase pump, which these are mostly used to boost the pressure in order to get the flow all the way through the flow line with the correct pressure, so that they are used for that. And some compressors are also used to compress water or gas and send it back into injection wells, so that they maintain a fairly good pressure inside the reservoir. The last slide here in this presentation, we're not going to watch this one. It's I think it's 43 or 44 minutes long, but it's a good documentary about the troll platform outside of Bergen. So it's the one of the guys from Top Gear, Richard Hammond, if you know who he is. He's the guy that's doing the documentary, and he's just been looking at the engineering aspects on this one. So there it is to have it ready. This one will be made available with the along with the lecture on Pronto, so you can watch it one evening if you want to. So instead of watching comedies or something on TV, you can watch something that's relevant for your studies. And it's a really good one. I've seen it before, so it's a good documentary. So then we're done with Appendix A. Finally. It's a long haul getting through that one. So now we're going to Appendix B, where we're going to look at, first we're going to look at Åsgard, which is one of the fields off of Norway, and then we're going to look at Ormenlange afterwards. Okay. So first off, I've got a couple of slides which aren't in the appendix that we'll look at. First off, it's just to show a bit where the Åsgard is situated. We're around here, down here, and we've got Bergen around here. We've got all of the coastline up here, and then Åsgard is more or less to directly outside the middle of Norway there. Maybe you didn't know this, but from the southernmost point of Norway to the northernmost point, it's actually the same distance as from the southernmost point and down to Rome in Italy. So it's a pretty long country. So when we say we're halfway there, it's pretty far off still. So it's a long distance getting up there. So it's out here, and we have a small clip with the installation here. Show. So this is inside the fjords of Norway. No, it's not the fjords of Norway, by the way. That's where the seabed is. So this is many millions of years ago, and now everything is being covered by sediments as the millions of years go past. And it's becoming the sea floor, and then we're going to get reservoirs and stuff in here. So we have really poor lighting here. I'm trying to. Didn't really help. So it's showing sort of the layers of rock underneath there, and where the natural resources are being caught by the rock, the harder rock, where it can't escape, so becoming a reservoir. And now we're seeing these are the pipelines that are running. We have several of the subsea structures here. We have the floating rig with all of the risers, and there's one of the other ones. And here we have some more subsea modules placed in, or templates rather, not modules. We're going to follow the risers up to the surface vessel, and here you see at the bottom of the vessel here, you can see that everything is on a circular disc almost, and this one can rotate, so that it allows the ship to rotate, so that they can place its bow, the front of the ship, towards the waves, without sort of entangling the risers completely. That was an introduction of the field there. We've already seen this one a bit, where we were looking at the 42-inch pipelines. They have two production flows, one gas injection, then they have heating, and then return for the heating fluids. And it's really huge, this pipeline. We've also looked a bit at this one already, which shows more of the umbilical that's going down into the templates down below, just following the risers basically. Already looked at this one. And here is what was it called? The host module. I think it is. Isn't that the host module? No, that one isn't the host module. We'll get to that one afterwards. So this is a template that has 4 different Christmas trees inside it. And this one in the center here is the flow control module. So this one is controlling it. These are the pipelines that are going into it. So this one is sort of the equipment that decides what goes where into which pipeline. And it also has a subsea control module. If I remember correctly, it's embedded inside this white structure. And also you have the manifold there with the pipelines connected. So here is a sort of schematic to show how everything is connected. So we have well slots down here. We have well slot number S1 and S2, called. And here we have well slot S4. And this one is well slot S3, which is the same as these other ones, only these ones haven't been expanded to show what's happening inside the well. So this one has been expanded just to give you the details of what's happening inside. So we can recognize this one. We have the surface control subsurface safety valve down here. Annulus master valve, we are moving up. We have the production master valve. We're going over here. Production wing valve. And the wing valve for the annulus also. All of this goes into here. Now we have the control parts. No, that's the tree cap, basically. This is the tree cap parts. And then we are getting into the manifold. So this part here is the manifold itself, where they are getting a lot of flows from all of the different wells, and they are combining them where they need to combine them, and they are selling them off in the pipelines. And these yellow ones, they are the pipelines, S102 and S101. And as you can see here, if we follow it upwards, it makes a curve up here and back down. So remember, we've been talking about pigs. So this is basically a way of looping the pig back. So you can send it down one of the pipelines, and when it gets to the manifold, it loops around here, and then it goes back the other pipeline. So you can do both pipelines in one go. There is a 3D model of the manifold itself, as it looks like. We are connecting the pipelines there and the umbilical in the center. And these are connected to the Christmas trees of each well. And you can see there's a whole lot of valves that can be operated on top there. So those are ROV operated valves. So it will come in and operate. Yeah? Yeah, we'll do the break now. So I think we'll do the break, and then we'll continue on with what's actually in the book. We're going to look at the host system in the Waschal field. You can see here, host. I couldn't quite remember what its abbreviation for. It's a very technical abbreviation. I can't quite remember it now. It's not written down anywhere either in the appendix. But I'll check it for the next lecture, just so that we're completely sure on what it is. So for this host system is basically you have the production control system, where you have the umbilicals. You have the different sections of the umbilicals shown here. There you have the inner parts. Here the inner part has been removed just to show a bit more, and here it's been covered up. So it's just to show different kinds of sections of the umbilical. So it's the same one that we've been looking at earlier here. So this umbilical here has just been stripped a bit to show the parts a bit more. And as you can see, you have the production control system up top. The umbilicals go down. We have these buoyancy elements to create this sort of loop, not loop, but this curve, so that we allow for movement of it. And this one is connected to this template, where we have it's the same template as we were looking at, the 4 wells on the sides and the manifold in the middle. And you also have a workover system when you're doing workovers, exchanging modules and stuff. So this one can be lowered down on top of here. We can lower down the running tools, everything, we can connect them. Here you just see sort of the top that would be here instead. And then also you have an intervention system. So the intervention system is when you need to do more light work, just exchanging a module. You don't have to go in with a wire line and into the well and do all of that stuff that you do with the workover. So with the intervention, you're just exchanging the less critical components on the templates. So you have shown on the side here, they've shown the templates and manifold a bit more. So you can see the bottom part here. That's the base that's beneath all of this. So that's the base. And you have these holes on the sides. That's where the Christmas trees are placed. So they are placed through those holes and down into the wells, of course. And then you have the manifold part that's in the middle of this one. So we're going to look a bit more at this base section, how they are going to do when they're going to install these, or how they did, not how they're going to do, because it's already been done. So they have them stored on top of the ship, on the deck. And as you can see, they have sort of lifted these parts that are sticking out for the Christmas trees. They have been lifted up, hinged for 90 degrees up, so that they are pointed straight upwards. That's for when they are lifting them and lowering them down through the surface of the ocean. They're going through the waves and everything. Is to avoid having stuff sticking out and creating a larger surface area. They have flipped these up instead, so that they get a smaller surface area. Because again, if you do a belly flop when you're jumping into water, it hurts really much. But if you dive with your head first and sort of just break the surface, it doesn't hurt at all. So it's the same principle that they want to do here. They want to avoid having a large surface area hitting it, because that's a lot of force. So it's still going to be a lot of force hitting it underneath there, but at least you are minimizing the area so that you get less force that way. Which also means that the equipment itself doesn't have to be able to handle such peak forces as it would be with a belly flop for the equipment when it was lowered in. And also the crane and the equipment of the crane, there is a really dangerous possibility here that when it hits a wave, if the wave hits back really hard, if the wave is coming up just as the equipment touches the water, it's going to lift the equipment because it hits it so hard, and it takes a little time before it starts sinking into the water. And then when it's then lifted, you can get slack in your lifting wire. And if it's then suddenly lowered back down again, because the wave is going up and down, so then it's lowered back down again. Once this slack suddenly tightens again, you will get a huge amount of tension in your cabling, and also for the crane, the boom of the crane and everything. A really dangerous load to get on it. So you can actually risk either the lifting wire itself snapping, or that the crane boom can actually start breaking, so that it can start just folding up basically. So it's very, very important that they avoid getting the slack in the lifting wires. They have equipment that will sort of pull in the slack very quickly, but it still reacts. It still needs some time to react, this equipment, so that it can still happen. So they try as best as they can to avoid those situations where you can end up with a slack in the line. And as we continue on now, we see that they have they've lowered it into the water, and then they've extended. I have to check here that we are going the right way here. Yeah, they lowered it down. They lowered it down almost all the way, like this, and then they reach the seabed. That's when they flip them back down again. So most of the way through the water, they are flipped up just to minimize drag, really. So we're going to look a bit more at drag calculations. But that's the same point as if you're in the pool and you hold your hand flat and you try moving it through the water, you can feel a lot of resistance. But if you put it like this, you won't feel that much resistance, because you are getting quite a small area that's pushing against the water. So you are more like cutting into the water instead of pushing a lot of water in front of you. Because what you can actually think of there is that as you are pushing your hand like this through the water, there is actually a part, quite a huge bubble here of water that's not being moved at all. It's just staying there on top of your hand as you're moving. So you have to move the weight of the water, and then you also have to push all of the rest of the water away on the outside of that. And that's going to happen underneath the module as you are lowering it also. so it's a drag resistance and stuff. So they wait with flipping these down until they are almost down by the seabed. So that's when they deploy these sides out. And then they do the lower down this guide funnel for guiding it, and guiding the drill string through the guide funnel. Then they install, for the next one here, they install a ROV panel, so you can actually see the ROV there. It's not that easy to see it up here, but if you look in your own appendix, you can see the orange ROV there, and there's an orange panel that they're installing. And now they're coming down with the base plates for the Christmas trees, and they're placing them in the correct positions on these four arms, basically, that's been extended. And these are the guide posts used. So here they are lowering down a blowout preventer. So it's placed on top of the base for the Christmas tree. And so you can think the blowout preventer is really heavy, and these arms, they have been folded out there, so they can take a lot of weight when they are placed as they can take a lot of weight this way when they are being loaded up with a huge BOP. And then they move along from well to well. They drill their wells with the BOPs on top. Once they've done that with all the wells, they put on caps just to seal them off. And then they deploy the manifold. So the manifold is still waiting on top of the vessel. They put the manifold down into the center there. I'm guessing that there might be collisions between manifold and blowout preventer, so that's why they haven't put the manifold down before they put the blowout preventer and drill the holes. I don't know the exact reason why, but that's just my guess here, why they are doing it in this exact sequence. And then they are putting down what they're calling the XT stack, which is the Christmas tree and the flow control module and the subsea control module. So they install those on all four wells. And then they use the running tool, like we saw with the choke module for the Christine field. So they use running tools where they have connected them with an inside elevator, which will lower them down once it's in the correct position. Now they are putting the blowout preventer on top of the Christmas tree, because now they are going to complete the well. So now they are going to drill it all the way and complete it. Make it ready for production. The next one, they have completed 2 of the wells, so they are ready to start production. So they can connect the umbilicals to the manifold. And for the next one, they have completed all of the wells, and now they are connecting the pipelines also, or the flow lines. And then they're completely finished there with everything. So this part on top of here, that's the protective roof that's going in. And I think they've just, for clarity, they've chosen to just remove the protective structure, so they're not showing the protective structure. But this roof will of course be connected to the protective structure. This wasn't a very good picture in such a dark room, but this is actually a picture of these host modules as they are on land. Let's see, but you can basically see it here. So you'll have to see it on your own screens when you get the presentation now, so that you can see it with a bit more color. But it is a really dark picture, so it's not that easy to see it. Here we have a clip from Ormen Lange, which is the next one we'll be looking at. And this is it's Shell that owns the Ormen Lange field. starts off here just by showing hydrocarbons, basically molecules in the reservoir. An artistic start to it. Moving up through the water. Wasn't down. I think maybe it was down. Sort of explaining the formations of these hydrocarbons and the reservoirs at the beginning here. Now they're starting to drill. There it shows us a highlight of the reservoir. So they drilled all the way down into the reservoir. That was basically a view from inside the pipeline, just to show that we're pulling up the hydrocarbons from the reservoir. Now we're up at the sea floor. It's really dark. Here we can see that this is the protective structure on the outside here. Now it's showing us the flow through the pipelines inside the templates. And this is to show some of the problems that they have in the Omen field, that they actually got a lot of formations inside the pipelines that were sort of clogging the pipelines. Because large stretches of the pipeline there was actually at a negative degree Celsius. So it was -1, -2, instead of staying at 4 degrees Celsius as it usually does by the seafloor. This is sort of to show that everything is subsea. There wasn't anything up on the surface. So everything is subsea and being sent into to land in Norway in a place called Aukra. We have this huge processing plant. There you see the flow lines, they're coming in through here, and then they enter the processing plants. Have the fluid flow going through the flow lines into the processing plants. spreading to the different processes that's going on in different locations in the processing plant. So this is a separation unit, so they're separating like water and stuff that they don't want in the flow. They're separating it out, getting pure gas out of it. So we get the flow line coming from the sea into the different processes there, being sent further on. There's a lot of back and forth, as you can see. Then we actually have something being injected back in. Because on Ormenlange they're injecting quite a lot of fluid there. So they have subsea injection wells where they are putting back some of the fluid. As you can see, this is really quite a huge area that we're using to do all of this. And then you think about most fields are doing this on a rig or on a floating vessel or something. So they're putting all of this equipment, which is spread out on this huge of an area on land. They are just compressing it completely into a rig or a vessel. So it's quite a feat actually to be able to do that. But safety-wise, it's a lot better to have it spread like this, because if something happens in one part of the plant, you can manage to shut down stuff and avoid having follow-on accidents happening further on. It's a bit more difficult when you're on a rig where everything is so close together. If you have something if you have a valve that explodes or something, there you can quickly damage some other equipment that will again damage more equipment, and then you have sort of a chain reaction going on. Remember how long this one was? That's almost finished. View of the entire plant. I think Torbjørn has managed to get you a visit to Kårstø here, so that you will actually get to have a walk around with one of their guides to get to see the plant there. Which is fairly similar. If you've seen one of these processing plants, you've mostly seen all of them. The differences are, of course, what kinds of processes they are running and how they have done their layout and stuff like that, but you will get a very good impression. As long as you've seen one of them, you will have a good impression of what's going on in a processing plant. So now we're back to the appendix that we're looking at. So there are three sub-projects that they're putting up here. We have the offshore part, we have the onshore part, and we have what's called Langeled, which is a pipeline that goes all the way from basically past the middle of Norway, up north, and then it goes all the way along the Norwegian coast and all the way to Great Britain. So it's a huge pipeline. It's really, really long. And here you can see the total investment phase. This was in 2007, or up to 2007. So then we had 50 billion Norwegian kroners, and that's the value it had in 2003. So it would be more in today's Norwegian kroners, because the value of it has changed a lot since then. So we have a lot of subsea structures in the field. We have Nyhamna, which is the area where it goes ashore, alongside Aukra there. And here you have the export line, which goes to Easington in Great Britain. It goes past the Sleipner field, so it's I think it's actually connected to the Sleipner rig. So that one also exports to Easington. And that's the Langeled project. And then you have the flow lines that are going quite far out to sea here, and then they hit a ridge, basically. So all the way out here, you have a fairly easy terrain. Oh, it wasn't really easy. It was really jagged because the what's it called? In the Ice Age, when Norway was covered with ice, the ice was flowing over here, and it was just really carving up the seabed, so that it's pretty difficult to find a good route for the pipeline through here. And then they get to this point where it just drops completely down to around 1 kilometer of depth. So it's really deep down this one. And they have two umbilicals, umbilical A and B. And there's also a 6-inch monoethylene glycol line that's injected in here to avoid freezing in the pipeline. And then we have the production pipeline, A and B, which are the red ones here, coming up. The reasons they are running A and B, from both one for A and one for one called A and one called B. They are all connected to all of the templates down there, but it is really so that they can shut down one of them if something happens. So that if they have a problem with the pipeline A, if it's starting to choke up with debris inside it, they have to run a pig through it maybe to clean it up. Then they can shut down that one and keep producing in pipeline B. So that's the reason why they have two, and also that's also the reason why they have two umbilicals, so that if something happens to one of the umbilicals and they lose contact with the subsea part here, they can just switch to the other umbilical. So then they have control again. So in between the 4 different templates that are down here, there are 16 inches multi-phase pipes. So the wells are getting both gas and oil up, and then they are sending them through the multi-phase pipes into the flow lines, sending it all the way up to Nyhamna, where they are separating it, and the gas is sent back. Because if I remember correctly, for this field the gas wasn't of that good of quality, and it's not that high of a percentage of gas compared to oil also. I think was it the oil? It's something like that. They're at least separating it, and some of it is being sent back in here to be injected. And as you can see here, template C and D was planned back then. They have been put into work now. So this was 2007 last updated. Yeah, and we see here we have a pig loop placed in the middle there. So instead of having the pig loop in the manifold, sending the pig around there, we have a separate one placed between all of the templates, which functions as a piglet. So then you have smaller pipelines going between the templates and the manifold, and the pig can clean the 30-inch pipelines instead. So a couple of facts about the production system. There are 8 production wells in each template. So there were 2 templates operating back then, now there are 4. They have quite a lot of wells operating. And each well can produce 10 million standard cubic meters per day of produced fluid. And the minimum stable flow rate for a well is 0.5 to 2. So if we get lower rates than this, basically the well won't manage to push the fluid out anymore. There's not enough pressure inside the well to push it out, and it will cease to produce. So that's the point with re-injecting stuff. It's just to try to keep the pressure up so that we keep the stable flow rate above 2 million standard cubic meters. So the selling gas rate of 70 million standard cubic meters is it's equivalent to the receiving pressure in EHAM of 90 to 120 bars. So that's the pressure in the pipeline, between 90 to 120. So in the pipeline itself, it's not really that high a pressure, but well, 120 bars is quite a high pressure, but not compared to what's down in the well. And they also need to produce some gas in order to limit the fluid buildup in the pipeline. So they have to have 20 million standard cubic meters there. So the structures of the templates is that they are held in place by suction anchors. So if you remember from one of the first lectures, we looked a bit at suction anchors. So these are just really huge pipes that are placed onto the sediments, and then they pump out the water inside them, so creating a vacuum, and it sucks itself down into the sediments, and it stays in place there. And then they have a replaceable manifold module placed on top of there. And then they have protective structures with hatches for every well slot. And they have also hatches for the connection points, pipes. And these are, the protective structures here are trawlable. So fishing vessels can, if a fishing vessel is close by and doesn't really realize that there are structures down by the seabed here, it should be fine. So the trawl should just pass over the structure. But I think there's still a sort of quarantine area where they aren't really allowed to fish there, but they've still put the protective structures up so that just in case someone strays into the quarantine area, there won't be any damage. So they had a lot of challenges on doing this one. Extremely uneven seabed for subsea and pipeline design and installation. As I talked about the ice that had carved loads of so narrow gorges and stuff in the seabed. And also, as you saw with the drop down to about 1 kilometer, that's an area where you can get underwater avalanches. So it's sort of, they have to keep that in mind, that if there is a small earthquake up in the sea or something there, it might actually trigger an avalanche there. So they can have parts of the seafloor just running down, sliding down and onto the production area. So they are keeping a watchful eye on it. And also the extreme temperature, minus 1.2 degrees Celsius at seabed, which was a huge problem. Because all NORSOK standards and stuff, they say 4 degrees Celsius is the norm. That's what it's more or less constant all over the seafloor. But in this exact area, it's minus 1.2. And the explanation I've gotten for this is that it's a sort of an unfortunate combination of sea currents and densities of water and stuff like that. Local salt content is a bit different there, so it's just an area of the seafloor where the currents are creating very special conditions, which means that it ends up becoming colder. There are also challenging waves and winds. It isn't a problem during regular production, but it is of course a problem while they are installing everything, because they need to have the vessels out there when they are installing it. And there's the strong currents, of course, that is one of the reasons because, for the cold temperatures. And then you have the water depth itself. When this was done, there wasn't really that many developments that have been done in really deep waters, so it was one of the first to do it. And there's quite a lot of production going on for subsea wells, just having these four templates now, or 2 back then. There was quite a lot of production going on, so they were producing a lot of fluid. And then they have the long tieback, as it's called, which just means that instead of sending it up to a rig, which is fairly close by, they have to send it way over to the shore and in there. So it's quite a long distance to transport it before they start processing it. So nowadays, if they had been thinking about developing this field now, if they hadn't done it back then, I'm pretty sure that they would have put quite a lot more of the processing equipment down subsea there, just to try to do as much as they could before they sent it back to shore. So we'll look a bit at the area. You can sort of imagine when you look at this ridge here, and you can see that it looks like it has been an avalanche there, and that's a very old one. So it's 8,200 years ago, which was this Stor Egge, which was the avalanche or slide that happened down there, which was this huge one. But as you can see, it's pretty steep when you get up here, so there can still be new avalanches happening there. And only a new ice age will bring about such a huge slide as this. So it's not going to happen that we're going to have a huge one, but you could end up having small ones right around where the flow lines are going and stuff. So it could be a danger. So you have to keep a watchful eye on it. So here is the subsea part of it, the subsea wells placed inside this circle, and this yellow marker is just to show approximately where the reservoir is deep down. So the reservoir is pretty huge, but of course when they drill down, they start angling it so that they get quite far into all of the sides of the reservoir. Yeah, the fabrication of the first one, template B, started on May 18th in 2004. So it's not that old of a field, it's not 10 years yet. It's a pretty fresh one, actually. Now we have a picture of the manifold being lifted onto the template in Tønsberg. I am guessing that this is a test fit, so they are on land, they are placing it, everything together just to check that everything fits, so that they don't get out there and realize when they've got it all the way down to 1 kilometer below the surface, and then, oh, something isn't fitting together as it should. They have to do everything both once and twice and 3 times just to be sure that everything is going to go as planned when we're out there. And here the templates are ready for sail away in 2005. You can see there's they're quite huge, these templates. And in July, August in 2005 they did the template installation. And of course, July, August, those are the 2 months where the weather is at its finest out in the North Sea. So That's why they have chosen that to do it. They used a crane which is called the Saipan 7000, I think it's called. That's the highest crane capacity available worldwide. So they have 2 cranes on it, as you can see here, 2 cranes. And each of the cranes can lift 7,200 tons. So combined they can lift 14,400 tons. So that's quite a lot of weight. And then they have a new deep water mode, which allows quite a lot of hook load at 850 meters of water depth. Now they're getting into more real details on the operations. We're not going to go that deep into it. There's a picture of the template while they were installing it, so they're lifting it down to the ocean. And it actually looks like they have the manifold in place there, so it might be that since they had these huge cranes that could lift it, they chose to just lift down the entire thing in one go instead of doing it one by one. We'll look at a map before we finish off for today. There you see the city of Molde, which is the closest city to Nyhamna. And so this is where it's coming ashore, and this is the field itself. So we have 33 kilometers here, and we have 64 kilometers here, and then we have 26 kilometers here. So it's a pretty long stretch getting all of this out here. And then we have the Langeland pipeline, which is a story by itself going on here. So they started laying the pipes before they put the templates into place. And there's quite a lot of, they have to do this. You have to remember there are 2 pipelines and there are 2 umbilicals, so they have to do this quite a lot. I'm not sure if they used a vessel that could lay 2 pipes at once. I think most vessels can only lay 1 pipe at once, so most likely they will have to do this 4 times. Laying 1 pipe, then the other, then 1 umbilical, and then the other. So it takes quite a long time to do stuff like this, especially with that many kilometers also. I think we'll stop there for today. We'll continue on with Ormen Lange next week.